Hey folks, Federico here. This is what came out to be the first part of a multi-part, I guess two-part tutorial series on folding simulation and typed array in JavaScript. So what is what? Folding simulation is this very cool environment in which cells of a grid follow a certain logic, like in the game of life, basically. But in this environment, they simulate falling sand or water or other materials. And there are pretty cool examples online. I'm showing you a couple here right now. And so we're going to build this, but of course, a very simple version of it. Don't know if you're going to make it more complex later, but the first iteration is going to be pretty simple. And I'm also taking this as an example to show you how to use typed arrays in Max 9 with the new V8 object. We can use typed arrays, which allow us to transfer data from matrix to JavaScript and vice versa in a super fast way. And I just show you how fast this is in the course of these tutorials. This is what we're going to achieve in this video. It's not super exciting, but it's going to get much more exciting, I hope, in the next video. In case you can already download the whole patch, this one and the finished video from my Patreon, link in the description. And without any further ado, now let's jump into this tutorial. Have fun. Okay, so let's start from scratch. First thing we are going to do is to create our JIT world. Let's give it a name. Let's call it just FS, like falling sand. And then let's give it a floating one for the window. Let's give it a default size of 320 by 240. Let's give it, what do we want? Enabled by default. And for the moment, I guess that's it. Let's get here the enable attribute by right-clicking here on the input of the object. So we can enable and disable the object by clicking on this toggle. Can also get a JIT FPS GUI to check our frame rate. The frame rate is the same that appears here in the lower right corner above the audio meter here. So this is another indication of the frame rate. Okay, cool. So the first thing we need is going to be an input matrix, which will be our grid. And let me use for that my JIT Matrix Editor, which is this abstraction is actually a MFI object that you can download from my Patreon. I'll put a link in the description. It's basically an editable matrix, Jitter Matrix. So the idea here is that we want to have this grid, which represents our world, 2D world. We want to place sand particles somewhere in this grid. And once they're placed in the grid, they enter the simulation. So if we place the number 1 in this cell here, in the next frame, it will fall. So it will be in the second cell, and then in the next frame will be in the cell below, and so on. And then if there is a cell below the current cell that is already filled with the number 1, our falling cell will just stop on top of it. Okay, so the falling sand simulation doesn't really use physics, but logic. So it just works like this. If there is a cell that has a certain value, the cell above will check it and will interact with it using the logic that we're going to write, but nothing really simulating physical behavior. So that's our idea. Let's start using JIT Matrix Editor. And let's use JIT Matrix Editor and let's connect this to a JIT matrix to which we will give a name which is like the grid, or let's call it sand grid. Or it's not really accurate. Let's call it simulation grid, right? And if you connect this to the so if I bang here the JIT Matrix Editor, by the way, this is called JIT Matrix Editor. You can download it from my Patreon, link in the description. This matrix now contains this number 1 at that cell. The cell by default is 10 by 10, I think. Yeah, it's 10 by 10. This should be a 10 by 10 actually. I had to fix that. With shift click you can delete the cell value, and we can choose the cell value with the message cell value, or it's actually an attribute. So if we want to place, for example, the number 12, that will place the number 12. The number go up to 254 because it's a char matrix only, I believe. If we want to clear that mess, we can use the clear message. So cool. Actually, I want to keep it 1 because 1 will be the number that represents our sound cell. So good. Our simulation is going to run inside JavaScript. So for that, we need to create a V8 object, which runs the latest version of JavaScript in Max 9. And we're going to call it, I already have a file here, which I called falling sand tutorial.js. It's this file here, it's perfectly empty. So what I'm going to do is to first set the auto watch to true. This means that when this file is modified in Visual Studio Code, it's going to update it also inside the Max. And so we are going to work with matrices first. We are not going to work with typed arrays because I want to show you the difference between working with the two approaches. So the first thing we need is to create a jitter matrix, and this is going to be the mat sim grid. And I want to keep this convention where I prepend all the names of matrices with mat underscore, all the arrays with r underscore, and so on. You will see how I do that, but this really helps me in keeping the code organized. So this is a new jitter matrix. And let's give it the dimensions inside JavaScript, so all the various attributes. So the name is simulation grid, that's the first argument. Then the number of planes only has one plane because we only have one number per cell. The type, we are going to have it as float32. But actually, we can have it type as long. So we just need the integer numbers here. And the dimensions are going to be, let's actually create a variable for the dimensions. These are the grid size. And let's make it 10 by 10. Right, so that's going to be our grid size. I prepend it with R because it's an array with 2 elements. So that's the convention I was talking about. Cool. So let's now create the function where the simulation is going to happen. So let's call it like update. And we trigger this function from Max. So we need a way to first read all the cells in this matrix, in our input matrix, see if there is a cell with the number 1. And if there is, we check the cell below it. And then if this cell below it is empty, we will swap the position of the cell below and the current cell. That's the first thing we're going to do. So in order to iterate through all the cells in the matrix, we need to create a for loop. So let's say for let I equal 0, I less than our grid size 0, I plus plus. And then we're going to do the same with the j. So instead of I, this will be now j and array grid size 1, so the second dimension of the matrix. By now the matrix is a square, but it could also not be a square, it could be a rectangle, so we need to have 2 different values for the grid size. So let's get the value of the current cell. So current cell value is going to be mat sim grid getcell. And getcell simply accepts the index of the cell. The index could be an array or 2 numbers. It doesn't matter, could be either like this for a 2D matrix, or could just write it like this. Cool. And I believe this actually gives us an array. So even if the matrix has only one plane, I think this gives us an array. So I'm going to get the first element of this array. So let's say now if current cell equal 1, so it's actually a number 1. Let's just post the index of the cell just to be sure that this thing is working. So let's post I and j. Cool. So for each cell that defines this matrix that has the number 1 in it, it will post its index. So let's send this matrix inside simulation grid, and then let's call the update function from Max here with a message update. And cool, it found a cell with the index for 1, which is exactly the index of this cell. Let's try to put another couple of cells here. Or actually, let's put just another one because otherwise it gets too confusing. Update, Oh, and I forgot to go to a new line, so we can just create an empty post here. So let's do it again. Sure, I have to bank this matrix again, because this matrix has been recreated when we saved the JavaScript file. So it found another cell at 7, 5, so 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, and 5. Great. So this is working. So instead of saying just current cell is equal 1, this is a bit cryptic. It doesn't really explain what's going on. And if you will have more materials apart from sand, this will get pretty confusing pretty soon, pretty fast. So let's create a literal object which will function like a container for our material types. So we can use the actual name of the types instead of just abstract numbers. And let's call these materials. And this is an object with the sand, which is 1. And for the moment, that's it, actually. So here we say if this is equal material sand. It's much clearer than just writing 1, right? So if this is... Oh no, we have actually another material which is void. And this is number 0. Cool. So if there is a 0 in this cell, it's void. The cell is void. So actually, let's call it empty, not void. Cool. If current cell is equal material sand, we need to get now the value of the cell below that. So let's get the cell below that. So const cell below, that's going to be mat sim grid, get cell I j plus 1, 0, and j plus 1 because the cells, the y index of the cells in a matrix increases when it goes down. So this will be 0, 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so we need to say j plus 1. Okay, I luckily remembered that my face is covering the bottom corner here of the screen. So you know what? I will just hide my face for the moment. I will come back later to greet you, to say goodbye to you at the end. But it's much better like this. There is no risk that I will cover part of the code. So we got now the cell below. So let's say if cell below equal materials empty, then what we can do is swap the values between the current cell and the cell below. So we can do something like this. Mat sim grid set cell 2D, because it's a 2D matrix, and that will be I and j, and then the value we're going to set is materials dot empty, just again because we just don't want to write 0, we want to write something a bit more specific. And then we want to say that j plus 1 is now material sand. Okay, so let's try to do that and see what happens. I have to bang this matrix here. And of course we are getting an error, and says that it cannot read properties of null. I think that's because we are going over the limit of the matrix, because if we access j plus 1 at the last row of the matrix, it's going to just go out of boundaries. So we have to say if j is less than our grid size 1. So if j is less than the size, so in this case like 10, but this will not help us because if it's 9, it's still 9 plus 1 is still 10, so this should be actually 8. So you have to say grid size minus 1. So if that's true, we can go on and check for the cell below and do all our things. If the cell below it's empty, then swap the two cells. So let's see what happens if we do that. And we need to output the result out of JIT Matrix Simulation Grid. So let's go create another matrix editor and bang this matrix now and see what we got. So we got that the cell, so the sand, went all the way to the bottom of the grid. And that's because we are changing the grid while we are iterating it, which means that it first swaps it, right? And then when it goes to the next row, it says, okay, yeah, there is actually a cell with a 1, so I should swap it with the one below, and so on until it arrives to the last row. which is not what we want. So what we want is actually to have two matrices, and one is going to be just a temporary matrix. So this will be like temp same grid or something. It doesn't have any name, but it's the same characteristic of the simulation grid. So what we do is that we don't change the values inside the math sim grid. We change the values inside the temp sim grid. So in this way, we don't change the input matrix. We just change this temporary matrix. And then when all is said and done, we can copy the temporary matrix into our simulation matrix. So math sim grid from matrix. And this will be math temp sim grid.name, I believe. So let's see what happens now. Let's create a cell here at the top. Let's update. And let's bang here. Oh, sorry, I did update too many times, but you know what? Let's actually output a bang here every time we call the update function. So outlet 0 bang. So we can attach this here. So, okay, now it's working. When it arrives at the last row, it stops. So let's try to add another cell here. Oh, great. It even, it's actually set here to 0. But great, it's even checking that the send should not fall if there is a cell below. It should not go on top of the other ones. And that's because if the cell below is not empty, then nothing is happening. So it just stops the simulation at that point. Okay. So that's actually pretty good. Okay, great. So we got the basics for our simulation system. Let's try, if I want to clear everything, I guess I can send a message clear to both these matrices, but it will not clear everything because the temporary matrix is still filled with data. So let's create here a function clear and say math sim grid.clear. And let's say math temp sim grid.clear. Cool. So if we do that and send a clear message to our V8 object here, it should clear everything. Yeah. And maybe let's call the update function after we do that. So we can see that the matrix is being cleared right away. Cool. We can even automate our calling the update function here with like a queue metro. Can connect it to update, and let's try to put some, if we put some sand particles here. Oh, every time I add new cells, it will still also use the old cells here in the input matrix editor. So what I want to do now is to actually don't use matrix editor, but use a better way to input new cells inside our simulation. And we're going to do that by using the mouse simply and clicking on our rendering window. That will be awesome. So let's first create a GGL video plane, renders to FS. Oh, and you know what else we actually want to put on JIT World? We want to put Ortho 2 because we don't want perspective in our 2D simulation, right? This is a 2D simulation. We don't want to have any perspective. So let's put the camera to orthogonal projection, and we can do that with Ortho 2. Cool. So what we want to do is to simply set some cells value of this simulation grid matrix. So we can do that with the message pack set cell 2D. This will be the index and the value will be just 1 in that case. Let's, for example, try to set a cell at the position, I don't know, 3, 0, and then we send a bang here. And this should, oh, but of course, this matrix is of type long. So even if it's filled with the number 1, it will not show anything. So what we need to do is just to multiply that by 255. We can actually use a JIT gen here and say, let's actually do first like this. Let's create another matrix and give it 4 planes. This is also going to be 10 by 10. I'm thinking actually we don't need to have it long. We can have it a char matrix. So instead of long here, let's write char. And so I was saying, if the input, just switch the first component, if this is equal to 1, what we want to do is to output the color of the sand or something, like a bit yellowish. So that's going to be 0.1 for red, 0.8 something, and 0.1, blah, 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 for the blue. So if this is true, output that, otherwise we'll output at 0. So let's try that again. And oh, the problem with JIT gen is that it will treat everything as float 32. So it will treat everything in the range 0 to 1. So even if this input is 255, we will divide it by 255. So this will never be equal to 1 if that's a 1. So you know what? Let's just go with float 32 matrices. This will work actually well for our purpose because we can... Because with float 32 we can anyway have numbers, integer numbers, greater than 1, so let's just do that. And as you can see, our sand is falling, it's just not color of sand, and it's also interpolating, so it looks all blurred. So let's just say here interp 0, and there we go. Oh, it's actually there. The color of the sand. It's a bit too red, so I'm going to increase the value of green here. And let's try to input a new one. Oh, I forgot to add an alpha value. And these are matrices, so this is going to be actually the alpha, that's going to be the red, that's going to be the blue, the green, so 0.1, and that's going to be the blue, so now there we go. Let's make it a bit less, yeah, a bit more orangey. Nice, so as I was saying, we can now add more particles, more grain of sand, and cool. So this is all working. What I want to do though is to add the sand using the mouse directly by clicking here in the rendering window, right? That would be awesome. And in order to do that, I think I will do that in the next video actually, because this is getting pretty long already. So this will be the first episode. Second episode, we're going to place the particles in the grid with our mouse, and we're going to use the typed arrays instead of accessing matrices just like we are doing now. And we're also going to improve the falling simulation logic. So great. Thanks very much for following through the whole thing. You can download this version of the patcher together with the finished version from my Patreon by subscribing to the Patreon and becoming a supporter of the channel. That will be much appreciated. It doesn't really cost much, but it keeps the channel going. Without that, donations, there will not be literally this channel. So anyway, thanks again, and I will see you in the next video. Have fun in the meanwhile, enjoy the summer, if it's summer in your hemisphere, and I hope I will see you in the next part of this tutorial. Take care and see you soon. Ciao.